Welcome to our next installment of the Water Wonders. Today we're going to do some ocean discoveries, all with some online tools. My name is Tanya Ketsa. I'm with the City and County of Honolulu in the Stormwater Quality Branch, and I lead the Public Education Outreach team. So we do a lot of messaging about how to protect our waters and about non-point source pollution protection. Protecting our waters is definitely one of our caveats. So in honor of World Oceans Day, which was actually June 8th, and today is June 10th, so a couple of days ago was the day we are celebrating by leading you on some ocean discoveries. And then we're going to learn more about Papahanaumokuakea, the Papahanaumokuakea song and coloring book project that was created because it is such a hard name to say, but it's a really important marine sanctuary, a national marine sanctuary in the northwestern Hawaiian Islands that really supports a lot of life within our oceans, and is also being honored on Saturday, June 13th at a virtual event that we're in partnership with the National Oceanic Atmospheric Association. That's happening from 3 to 5 on Saturday. So I'm going to take us into, we're going to learn about, we're going to do discoverwater.org. This is through ProjectWET, Project Water Education for Today. It's an international organization that brings water education to educators as well as non-formal educators and parents and keiki children across the world to teach about the importance of water. So they created this discoverwater.org. And we're going to play this game here, the Blue Planet. So the Blue Planet.
Why do we call our planet Earth when its surface is mostly water? From space, our planet appears mostly blue due to the great amount of water found at its surface. About 3/4 of Earth's surface is covered with water. Relatively little of this large amount of water is usable fresh water. The rest is salt water in the ocean or is frozen as ice at the North and South poles. Think of it this way. If all the water in the world fit into a bathtub, about 30 gallons or 114 liters, fresh usable water would fill slightly more than 1 teaspoon.
Oh, crazy. So we're going to play and find out how much of the world's water is ocean. So we select a location at random, and then we'll start spinning, and then we'll have it stop, and then we'll note if it's ocean or land, and we'll do that 25 times. Here we go. Ready? Oh, that's water. And stop. Water again. I wanted to try to get the Great Lakes at some point. Oh, and land. We ended up in North Africa. And North America, closer to the Great Lakes. Here we go. Oh, water again. Let's see if we can get Antarctica. Oh, we almost got Australia. I'm going to count that as water. That was close. Oh, we got water again. Let's see if we're on the North Pole. Oh, we got landed in Alaska. Try North Pole again. Ooh, I can't tell. I'm going to count that as land. I think that might be Greenland. All right, let's see if we can get Hawaii. Oh, we ended up in Indonesia. Asia. Ooh, I'm going to call that one water. We're in Estuary, huh? And we're in Africa again. Land. I'm going to call that one water too. Let's see what we get. Oh, we almost got to Hawaii. Let's see. Oh, close again. It's such a tiny dot to get here. Oh, water. Oh, we keep getting closer to Hawaii. Great Pacific, back in Asia again. Almost landed it. Africa again. Where? I don't know what to call that land. And water. And water again. We made it. So 60% of all the little clicks that we just did, so 15 out of 25, 60% was water, and only 10% or 40%, 10 landings was land. So does this reflect the actual percentage of water on Earth's surfaces? So it's almost 3/4. So it was a little bit more land that we landed on than usual, but pretty close statistically. We're gonna, well, we learned about this. Let's see, oh, quick, there we go. You can, so I want to kind of introduce this whole little gaming to you so you can play it anytime. There's also this, what did I learn? And you can go through all these little quizzes. We learned that in a whole bathtub of water, only a teaspoon amount would be fresh water, right? It's so crazy. So you can play the quizzes. You can also do this take action button where you do this, you build this action poster. Say, I will recycle and reuse plastics and cardboard. I will shop smart by taking my own reusable bags and recycling plastic shopping bags. You can put those into your action poster, which you can print. And later at the end of your little session here, your science notebook also has really great, let you download a bunch of just at-home activities. I'm getting back. Okay. So next, I'd like to take us to the water cycle. Now that we've learned all about how important water is on our planet, on our blue planet, how much of it is water, I want to talk about how water cycles through the earth. Play this little activity. So, in the water cycle game, you can go through.
Where does water come from and where does it go? The water cycle is the endless movement of water around the planet. Earth's natural systems are constantly moving and using water. As a liquid, gas, or solid, powered by the sun and the force of gravity, water travels over, under, and above the surface of the Earth in an incredible journey called the water cycle.
All right, so you can play this water cycle activity, which allows you to kind of learn about precipitation. You move on precipitation here, yay!
Precipitation. Rain and snow
melting,
precipitate or fall from the sky.
The different processes that water will go through within the water cycle. And you can also play as states of water. So sublimation is one that not too many know about.
Sublimation. In rare conditions, solid ice sublimates directly to water vapor.
So yeah, you can place all of these other states of water and play that game. But I wanted to take you on the Blue Traveler game. So this really walks you through the water cycle and teaches you about the different places that water travels through as it cycles. And you also learn about those states of water and the ways that water moves, those processes. This is one of our favorites to teach in the classroom. It's called The Incredible Journey when we come in.
Lake.
So how we'll start is we get to choose which water drop we want to start as. So
Groundwater. Soil. Plant. Glacier. Lake. River. Animal. Ocean. Clouds.
So
Animal.
I'm going to choose animal. Since I am an animal, I'm going to start with my own self.
You are inside an animal.
So animals are living organisms that drink water and consume water in the food they eat. Animals need water to survive. And there's this little bit here you can click on to meet
Wildlife biologist.
So a scientist that would study animals is a wildlife biologist. There are other kinds of biologists that might study, but a wildlife biologist is the type of scientist who studies animals in their natural habitats. Wildlife biologists spend lots of time outside observing, studying, and protecting and managing animals. We're going to continue on our journey.
Bridger's Challenge. Answer the question correctly to continue along your water cycle journey.
A scientist who studies animals is also called not a glaciologist, a botanist, a geologist, but a wildlife biologist. We'll just find that. All right, we're going to spin this arrow and see where we go next. Remember, we're in an animal. Ooh, and now we're going to the clouds.
Respiration. As water vapor, you were exhaled through an animal's breath.
That's exciting. See the dripping.
You've arrived in the clouds.
So clouds are formed when water vapor rises, right? We respired and that water vapor rises, cools, and condenses into tiny particles of liquid or solid water floating in the atmosphere. Who studies this?
Meteorologist.
A meteorologist is a scientist who studies the atmosphere and weather. Meteorologists study clouds and weather patterns to be able to forecast the weather. So what is the main process by which clouds are formed? Condensation, that's when water comes together. Gravity, that's the force that pulls things down. Precipitation is when rain falls, right? When things fall. Or an electrical current. It must be condensation, when those particles come together. Right. Ding. Okay, let's spin our arrow again and see where we're going from the clouds.
Precipitation. You precipitated or fell as rain or snow.
We fell into the soil. We learned about condensation and precipitation.
You've seeped into the soil.
Soil is the top layer of Earth's surface that contains eroded rock particles and decaying plants and animals. Water can cover and stick to individual particles of soil and fill in the spaces to be in between particles.
Pedologist.
So a pedologist is a scientist who studies soil. Pedologists observe and map different kinds of soils and determine how the land and soil might best be used. Continue on our journey. Oh, a scientist who studies soil is called a pedologist. Very good.
Evaporation. You evaporated from liquid water to water vapor.
Hey, we did this before. Remember when we respired and then evaporated and went into our clouds?
You've arrived in the clouds.
Right, and remember it was the meteorologist that studies clouds. What factors contribute to the name of a cloud? The altitude, how high up it is, the shape it takes, the precipitation, the amount of rain it comes. I think it's all of these things.
Precipitation. You precipitated or fell as rain or snow.
I'm getting a little bit of precipitation outside, I think. Fantastic. We went through this cycle before where
You've landed in a lake.
Condensed and then precipitated. Then we landed in soil. Now we're in a lake. And lakes are large bodies of water surrounded by land and contain most of the surface water on the continents.
Limnologist.
A limnologist is a scientist who studies freshwater ecosystems. So limnologists study lakes and surrounding environments, including plants, animals, and people. A person who studies lakes is not a biologist, a botanist, it's a limnologist. So water droplets don't always move. You may stay in the same place.
You've landed in a lake.
For a long time. All right, so we already been in the lake. True or false, a lake can contain either salt or fresh water. That is true.
Flow. As liquid water, you flowed from higher to lower elevation.
We were in a big body lake. Now we're in a river.
You've made it into a river.
A river is a stream of flowing water with a definite course. Rivers move water from one place to another along the Earth's surface.
River hydrologist.
A river hydrologist is the type of hydrologist who studies rivers. River hydrologists conduct stream surveys to learn about how fast streams flow, how much water is in them, and how they can change over time. So being from the stormwater quality branch, we often have hydrologists or people who have at least learned about hydrology in our staff. A scientist who studies rivers is called a river hydrologist.
Consumption. You were consumed as an animal drank or ate you.
Nice. Wow, our water came back to us. We respired it and went through this other
You are
journey
inside an animal.
All right, and then wildlife biologists, right? Who they shared. So kangaroo rats are adapted to conserve water in their bodies by consuming water from seeds instead of drinking, urinating very little, not sweating or panting to cool. All of the above? I think it's all of the above. That's amazing. That's a lot of ways to conserve water. We stayed inside. The water stayed in us as an animal. Again, so a water droplet may stay in the same location for a long time.
You are inside an animal.
Continue our journey. I think we have one more spin. Name a way that animals lose water from their bodies. Do you remember what that was? Respiration. That was one. Urination. Yeah, when you go she. Perspiration, when you sweat. That's water too. It must be all of the above. Back to the
excretion. You were excreted from an animal.
He's urinating, right? He's excreting the water from his body and soaking into the soil.
You've seeped into the soil.
Right. Do you remember who studies that again? A pedologist. Pedologist studies soil. How is soil formed? From weathered rocks, from volcanoes, from decaying plants and animals? Actually, I think it's all of the above. That's why there's so many different soil types in the world. All right, I think we're on our last spin here for all these water droplets that we've collected over our journey.
Congratulations! You have completed your water cycle journey.
All right, now, so this journey, you can print this as a passport and start to connect where these different processes happened within our journey, and start to think about other things that are happening, like we mentioned, respiration and urination, maybe photosynthesis within plants, and how things go. We're going to quit this and actually move on to ocean habitats.
Where is most of the water on Earth found? About 70% of Earth's surface is covered with ocean. All ocean water on Earth is connected, creating one large ocean, which contains about 97% of all water on Earth. 5 smaller ocean basins are named Atlantic, Pacific, Indian, Arctic, and Southern. The ocean influences climate, weather, and landscapes around the globe. Oceans are essential for all life forms, including humans. Although humans live on land, our lives are tied to the ocean. Organisms in the ocean originally produced the oxygen we breathe today. We also depend on the ocean as a source of food, medicines, and energy. The ocean is home to a huge diversity of life, and new life forms are still being discovered as humans explore deeper and deeper underwater.
All right, let's try our activity. Oh, here we have this little scope. Let's see what's around here. Oh, look at this plankton. Open ocean or pelagic zone. Floating in the top layer of the open ocean are billions of tiny animals called zooplankton. Tiny plants called phytoplankton turn sun's energy into food. Together, zooplankton and phytoplankton are called plankton. Many larger sea creatures feed on tiny plankton, and these in turn are eaten by larger animals, making plankton very important as the base of the ocean food web. All right, so most of the oxygen we breathe was produced by tiny single-celled phytoplankton floating in the ocean. Phytoplankton produce oxygen through photosynthesis, just like plants. Plankton is the foundation for the ocean food web. Larger animals depend on plankton as a food source. The ocean really is this major, because of these plankton, this major cycle of a lot of recycling systems. Oops, I'm gonna go back. I want to read this for you. Hot water vents. Super hot water spews from cracks in the ocean floor called hydrothermal vents. Here, bacteria combine with chemicals to make food for worms, shellfish, and crabs found nowhere else. Hydrothermal vents habitats are still being explored. So, the hydrothermal vent octopus has eyes, but it is unknown if it can see. It uses other senses like touch and smell to find its way through the dark of the ocean floor. Not much is known yet about this octopus, but it lives near hot water vents and probably eats crabs and shellfish that in turn eat tiny organisms that eat chemicals produced by the vents. Is there another one? This octopus has no color and is so transparent its insides are invisible through the skin. Oh, that sounds pretty creepy. All right, let's see. A coral reef. Oh, I'm sorry, I wanted to read the little description for you. Coral reefs, tropical ocean supports brightly colored coral reefs, which are made of the tiny skeletons of soft-bodied animals called corals. Coral reefs develop over hundreds of years. The accumulation of tiny coral skeletons builds up to become homes for anemones, sponges, sea stars, shrimps, lobsters, crabs, eels, sea turtles, and fish. We're very lucky here in Hawaii to have lots of beautiful coral reef to visit. Reef fish help keep green sea turtles clean. Algae grow on sea turtles' carapace or shell, and fish eat the algae and clean them off. So, although sea turtles breathe air, adults can sleep underwater for up to 2 hours at a time. All right, that's all they have to share. Ooh, look at this guy. Midnight zone. This dark, cold zone ends on the ocean floor, sometimes more than 5 miles deep. Dead plants drift down from zones above. Midnight dwellers eat each other or dead animals. Small, weird-looking fish use light organs, body parts that glow, to lure prey and communicate. Fishing in the dark. The deep sea anglerfish fishes for its meals by waving a spine with a glowing tip located at the top of its head near its mouth to attract prey. This fish lives more than half a mile deep in the midnight zone of the ocean where there is no light. Although it appears ominous, this fish is only about 5 inches long and could fit into your hand. Those big teeth. It's kind of scary looking. Let's see what's over here. The kelp forest. Thick, swaying forests of kelp grow in cool ocean waters. Kelp is a kind of seaweed that provides habitat protection and food for fish, snails, sea stars, shrimp, sea urchins, abalone, and other creatures. This is really common along the California coast, these kelp forests. Sea otters tangle themselves in kelp to keep them from drifting while they sleep. Sea otters keep food in folds of skin under their front legs when they swim to the surface. That's interesting. Is that it? That was it? Okay. Oh, there's something. Sea otters use rocks as tools. They will place a rock on their chest and crack the shells of clams and mussels against it. They also use rocks to loosen shells from rocks underwater. Estuaries. Many fish and shellfish begin life in estuaries, the mixing zone where freshwater rivers meet saltwater. Bays, sounds, marshes, and sloughs are estuaries. They contain nutrients or food brought by rivers. Grasses and other water plants grow here, feeding and sheltering ducks, bald eagles, brown pelicans, alligators, muskrats, crabs, clams, worms, and fish. Estuaries are important as nurseries for human food, shrimp, crab, and fish as well. They're also really important for helping to clean the water that comes out of those rivers and protecting our oceans. Great blue herons live in many wetland areas and are commonly found in estuary environments that provide a source of food. The great blue heron makes its nest in trees near the water. These birds wade in shallow water and stab prey like fish and crabs with their long beaks. We have some herons here, some egrets. They kind of do the same thing. Okay, exit that. That was fun to explore our ocean habitats. And again, you can do your quiz, take your action. Oh, we already filled up our bag, I guess. Do a science notebook. This has different activities you can download as well. Now I want to take you to Papahanaumokuakea and to introduce you to this song and coloring book that was put together by an artist here from Hawaii, Patrick Jing. So he has this song coloring book. You can download this. You click here, and this coloring book comes up that has all these coloring pages. This tablet is not liking me to use the touch screen, but you have all these coloring pages, quite a number of them, really pretty drawings. So you can, there's actually a little contest happening right now. So you can download this, color one of the pages, and submit it. So our Facebook page, Clean Water Honolulu, has this post, and so has this link. You can download, there's the coloring book link, you can download, or you can also use these forms. And I will make sure to put this into the chat. But you can download the form and submit it. And you have to submit it right away, and you'll be a part of the event that's happening on Saturday. So coloring book, submit, see where you can find it through the Facebook, Clean Water Honolulu. But they've also, so this page, Papahanaumokuakeasong.com. You can view a video, which I'll share in a second. You can request a sticker, and there's also great links to the Papahanaumokuakea Marine National Monument site, where you can do some virtual tours, and the National Marine Sanctuary Foundation has some great resources to learn about this really important sanctuary and the different islands up there. Polynesian Voyaging Society has a lot of great resources as well. And Patrick Ching is wonderful and gives lots of free resources to learn about art and painting. So there was a song that he helped to that he wrote, and then it was
and now
performed.
Let's enjoy a beautiful tribute to Papahanaumokuakea by Kavika Kahiapo. This song is called Papahanaumokuakea. It speaks of the union between Papa, Mother Earth, and Wakea, Sky Father, who gave birth to the Hawaiian Islands, and especially the tiny atolls which lay to the northwest of the main islands. It also describes some of the plants and animals that inhabit the atolls, and why it is so important to protect this sacred place. Papahanaumokuakea, sacred islands way out there, born of Papa and Wakea, Papahanaumokuakea. Papa is the Mother Earth, Hanau means to give birth. Moku is the name for islands, Akea the Sky Father. Ancient islands towered high, rising up into the sky, floated by wind, rain, and sea. At those they would someday be. On the Aina plants would grow, Naupaka and Apoko. Papahanaumokuakea. Creatures cross the ocean blue, birds and fish and insects too. Onumokuakea, followed by some mahi-mahi. Many birds make homes of these, atolls scattered across the sea, nest in shrubs and on the land, some dig burrows in the sand. Some birds come here for the winter, migrate north for summertime. Akikiki and Polea, Papahanaumokuakea. Kola start reaching wow, transcending from pole to owl. Giant creatures of the sea come here to Hanaukeiki. Ioholoikaua is Hawaii's native seal, dog that goes in the rough water. Papahanaumokuakea. Onu come from round the way, mate and lay their eggs out there. Nest will hatch under the oku, hatchlings scramble everywhere. Travel to by the ancestors, sacred sites upon the earth. Voyage to my hopeful Papahanaumokuakea. The tall and proud. Mahimanda sacred places and Namea Kakamai. Asmihoamokuanamanda, island of great spirit power. People went to pray up there, Papahanaumokuakea. Lavo is next in line, crescent atoll lost in mind. Onubaski on the shore, across the ocean floor.
All right. Let this cue play a little bit here. But we're running out of time, so the city's stormwater program at cleanwaterhonolulu.com. The website. Okay, here's the website. So I'll be doing more of these water wonders. I'll do a little bit more demos and maybe some field trips. But check our calendar. Calendar's on this main page. And also you can visit the Learning Center. This Learning Center has a lot of free downloadables. A link to the Aloha Aina online resources for environmental educators. Teachers information. We have lots of really great programs to do water quality monitoring. So please check out our website. We put a lot of great resources there. All right, so thanks for joining me today.